Welcome. In this series of videos, we will cover the design and implementation of a project, from initial design through coding and development to testing, using the PowerBasic Windows compiler. Today we will continue our project to look at the use of text prediction software. This was our application at the end of the last video. Our application allows us to take individual text data files and accumulate them into an array. And we have an additional icon to allow us to save that text data file back to disk. This comprises our training data. We can then load that training data into the application. And once we start typing some text, after we have typed 2 words, we get a list of possible words appearing in a list box on the right-hand side of the dialog. So what we're going to do today is to allow our user to select one of the possible words and it to be automatically added to the text in the text box. So let's have a look at our code. We're going to make some changes to our application today to allow it to handle even more bulk data. When you have an application that has a dialog and there is some background processing happening, you may well find that while the background processing is running, the dialog will display not responding. This is because all the processing power is being taken up by the back-end processing. So we need to put some events in to populate our dialog progress bar as the application loads its data. So we're going to do this using a couple of custom events. So we're adding these as constants to our application, one called progress event and one called progress event completed. These custom events will be triggered to indicate to the dialog that it needs to upgrade the progress bar. So we can now go to the callback event, the event handler of the dialog, and we can insert our new custom events. These appear above our WM command section. And there are our 2 new events, progress event, which will set the progress bar to a specified value, which is coming in with the CBW param. And it's also setting the text on the status bar to say which file it's actually loading. And once the loading has been completed, we can then trigger the progress event completed. It will set the control set text to loading completed. So as you can probably guess, we will also need to make a change to the process files function to trigger these 2 new events. Where a single file is being processed, we can leave the code as is, since the backend processing will run so quickly that the dialog won't have time to time out. So the change needs to be in where we're processing multiple files. So we can remove the section where we're setting the text on the status bar, as this will be carried out by our new events. And we can also take out these 2 lines of code here, where the progress bar is having its value set. And we're going to replace that with a dialog post event. We're still using the progress set range command to set the range of the progress bar. But as each file has been processed, we can then call a new command, dialog post, to send a message to the dialog to that particular custom event, in this case progress event, to update it for the value we wish. And we're sending 2 parameters, the first being the file number we're handling, and the second being the upper bounding of the array. And we can then call a dialog do events to give the dialog a small time slice to actually process that event. And at the end, when the files are loaded, we can take this line of code out and replace it with a dialog post command as well. This one will be posting the message event completed. So this will allow us to display a progress bar to the user and allow the dialog not to show the message not responding. Also, as a matter of interest, we may want to put some metrics in while we're developing. This metric will tell us how long it takes to process each file. So we're going to add a new constant at the beginning of our application, and we're going to use this to specify the name of a metrics text file. Into this metrics file, we can write details for how long it takes to process each file. This allows us to determine if the time taken to process each file is increasing. And there is our new constant, metrics. So if we look at the function that processes the files, the first thing we want to do is to raise the metrics file should it exist. And this can be done quite easily in a try-catch block. If the file exists, we delete it using the kill command. If the file does not exist, then no error will be generated to the user. And as we process each data file, we can write to this metrics text file. So if we have a look in the process file function, we can set up a timer at the beginning of the application using a quad variable. And at the end of that function, we can then update the timer variable by subtracting it from the current timer. This gives us the number of seconds the application took to process that data file. And we can then append it to the end of our metrics file. So if we try compiling that now, so if we run the application now, and we can set up our text data. We pick our 10 files, hit open, and that's them processing now. So we'll let all 10 files load, and then we'll have a look at our metrics file. And there's our loading having been completed. So we will save our text data, and then come out of the application. And there is our metrics text file. If we open that up, we can see the number of seconds it takes to process each file. So it ranges between less than 1 second to a full 3 seconds. So as we found in the last video, if we're processing a large number of files, it can take a long time to process. So we want to look at that issue to see if we can make the application a little more performant. Since the function of our processing is to look for patterns of 3 words, and these are to be added to the array, which is global. So let's have a look at the code where we add data to the data slot. So here is this function, taking as its sole parameter the 3-word phrase which is to go into our data slot. It's already been checked to see if this phrase already exists in the array. And in this case, if it's not found in the array, we call this function add to data slot. So the first part of this function is looking for an empty slot. And every time we wish to add to this list, it's looking again to find the next available slot. This is not particularly efficient. So there has to be a better way of working out where the next available slot is. So we're going to create a new global variable called maxEntry. This is going to be used to store the next available entry into which we can write. So currently, we are working out what the maximum number of the array is, what the upper bounding is. So the first thing we have to do is to increment the maxEntry variable. This should take us to the next empty slot. If that number is less than or equal to the upper bounding of our array, we can go ahead and slot the data straight in without reading through any further in the array. So this is our new processing. We will use maxEntry to hold the value of the last populated empty slot. We'll then increment that value to move to the next slot. If that number is less than the upper bounding of the array itself, we can put the data into the slot. And then set the word count to the value 1. We can then exit the function immediately. If this value is not true, then we will redimension the data in the array, as we did before. And the only difference being, we can just change these variables to designate the global one. So a very minor change to the application should make it more performant. So we can specify this new global variable at the beginning of our application. And if we try running our application now, and we click to accept our test data, hit open, And as you will see, it does load remarkably quickly. And we can then save that text data. So we've now got past the performance problem of our application, so we should be able to feed it with a great deal more data now. So the next thing I want to tackle is the data going into the text box. As you will see, when the data goes in, it's not folding the text down to the next line. So I'd like to put something into the code to allow the application to handle that. So once more, back to the code. So I'm going to create a new constant to specify the number of characters after which we're going to fold down to the next line. And I'm also going to create a global variable for the handle of our main dialog. So in order to give us more control over what happens within that text box, we're going to do a bit of subclassing of that control. So if we have a look where the dialog is specified. So this is a function which displays the dialog to the user. So we're first going to store the dialog handle in the global variable. Next, we're going to set up a piece of code which allows us to subclass our text box event handler, the callback function. So we're going to use a couple of Windows API calls here. First of all, we're going to get the dialog item to give us the window handle, giving it the two parameters of the dialog handle and the handle of our text box. We're then going to set up this new variable called oldproc. And we're going to use a new function which will contain the code which is going to do our event handling for the text box. So this means any code we have that handles our dialog handling within the main callback function can be removed, and we can now put this into our subclassed function. So we will now create our update text box function. So this is the skeleton of our new function. As you would see, it takes 4 parameters. These are the parameters which are used for the event handling: the handle of the window, the message that's being processed, the W parameter, and the L parameter. And we're storing in our oldproc the value of our old process. And next, we're going to put in a select case statement. This to handle each of the types of messages we're going to be getting from the text box. So the first will be a destroy event. This is when the object is destroyed, when a dialog closes down. Next, we're putting in an event called wmchar, and we're calling another Windows API call here to invalidate the rectangle. So we're basically doing nothing on this event for the moment. The next, we want to actually test when the user finishes pressing a key. That is the key up event. What's happening within this event will look familiar. We're calling the two functions we did in our original callback function. We're doing a call to trim text, and we're also calling the process text change function. The remainder of the code in here is going to be one function called wmpaint. This is to paint some information into this window to give the user some feedback. What this function will do will put the words type in here in the very center of our text box, and it will display this in grey. So if we run the application now, you will see the change that has been made. The words type in here are appearing in grey in the middle of our text box, and once we start to type, they will disappear. And once all the text has been removed, the words will pop back again. This is a technique to give valuable feedback to the user on what to do with the text box. So our next task is to handle the data in the possible words list box. If we load our training data and start to type, we want the user to be able to click on this and actually put this information into the text box. So let's go back to the code into our event handler and create the event to handle clicks on this list box. Currently, we have no code to handle anything that happens on the list box. We can remove this section of code here as the functionality is being handled in the separate function we created a few moments ago. So we can take that out completely. So this is the event we want to handle when the user has clicked on this list box, using the button clicked event. First of all, we want to get the item that has been selected and pass that into a variable. We'll call that variable item. We can then get the value of the text at that item and pass that to another variable which we'll call selected, which will be a string variable. Next, we will get the text that currently sits within the text box using the control-get-text command. We can then push that information back out to the text box by adding on the selected variable to the end of str_data, followed by a single length space. So to ensure that the data doesn't exceed the width of the text box, we can call the trim_text function. So as we've now added a new word onto the end of our text box, we now have to repopulate the list box to get the next set of words that the user can click on. So we can get the str_data value coming back. We can then call the process_text_change function, as we've done before, to repopulate our list box. So before we run our application, we have a few new variables we'll need to add to the beginning of our application. And now we try running our application. Let's see how far we've got. If we load up our training data and start to type, and there we have our list of possible words. So if we click on one of the items on our list box, it populates into the text box, and we now have a new set of words which we can now select from. And this can go on indefinitely. Now our text is wandering slightly off the page, so we may have to reduce the number of characters slightly, but the folding round has actually worked. So what we've achieved so far is we have managed to get the text behaving itself. Now occasionally we will find that the possible words don't match what we want to type, so we'll have to click back into the text box and type another couple of words. And then the possible words will pop back up again. So before we complete today's video, let's look further at the code we have generated today. One of the useful functions we've added to our text box today is the trim_text function, to ensure the data doesn't go beyond the size of the text box. We set a constant at the beginning of the application for 65 characters. This was a rough guess to ensure that what the user types will always be visible to them on the screen. We're making use of an inbuilt PowerBasic command called split. This inbuilt PowerBasic command called split has an option called word. When used together, these two can take a string of text and split that string of text into two, and it will do it on a word boundary. This means you don't have to write any special code to work out where a word begins or ends. This will do it all for you, and it puts the value into two variables, the first piece of text and the second piece of text. You can, of course, put this in a for next loop to go down a large piece of text and split it to any width you wish. And using this command allows us to actually fold the text down to the following line. At the moment, this code is only looking at the very last line of text within the text box. Should the user go further up the text box and decide to actually make more edits, including new lines, it would only work for the last line of text. However, we may actually amend this in a future video. The other item of note within this function is the use of control post. This is posting a message back to that specific text box. And we're using a selection command. This allows us to put the cursor at the very end of the text. The command can also be used to highlight a piece of text within a string within that object. But as we're using the end of text value, which is equal to the length of the data held in the text box, it automatically puts the cursor right at the right-hand side of the last piece of text. So in summary, what we've done today is we've enhanced our dialog to fold text down to the next line when the user is typing. We've created a subclass function to handle the events for our text box. We've also allowed the user to click on the list box to pick a word to add to the end of the list. And once that word has been added, we re-query the data held in our array to work out what the next possible word could be. And finally, we've improved the performance of the application when we're adding text data to our database. Hopefully you'll find some of these routines useful in your own applications, but that's it for today. Thank you for watching.